So we've got the liners drilled out, cut the relief down to about 55, and we'll see if we got to adjust that. Now we used heat to bend that a little bit, and it's not that much. Put a little bit of a taper on the Lockbar face. Now what we need to do is get the blade cleaned up, especially in this area where the pivot's going to ride, and you want that square all the way. Now this stock was pretty rough. It's got just some horrible finish on it. First off, we'll step over to the disc grinder and see how that does on getting these deep scratches and this foundry scale cleaned up. So this is 150 grit. I'm not sure that that will work real well and get it cleaned up, but we'll give it a try. So that's going to take way too long. I'm going to switch the grits down to about 100 grit and see about getting some of that deep surface scratches off. The great part about this feathering adhesive setup, on a PSA you destroy the disc taking it off, but with this feathering adhesive you get to reuse those. Using a 9x11 sheet is way cheaper than a PSA. So we'll line that up, and it's just wide enough. It's just under the thickness, width rather. Fair amount of pressure. And this grit's doing a lot better job. It's silly to struggle with a smaller grit when let the abrasive do the work. Okay, we got all the heavy scratches out of there, the surface foundry scale, and at 100 grit scratch, so I will pop back on a 300 or so and take out some of these scratches. That last one was a 150, pretty worn out. Now I've got a 320 on here. A lot better. I'm trying to apply even pressure all across it so I get the surfaces parallel to each other. All right, so we're good on that. Took all the foundry scale off, the heavy scratches that were on there initially. We're down to about a 320 scratch pattern. The disc is 10 times better than a flat platinum. When you're trying to get something flat on there on a small level, and this belt is pretty loose, just so I can show you this, that belt's going to try and, as you put it on the platen and it's rotating, that belt's going to pucker out a little bit, and then also it tends to gather at the bottom. And what happens is you get rounded over there and there. So if you're working, for example, on a full tang, and you get that rounded over just on that little part there, you put your scale on, you're going to see a gap along the top there, and along the bottom. So there's a couple ways around that. You can either make it quite a bit oversized and then grind back and get rid of that small little round over effect on both edges, or use a disc or hand lap that out. But a flat platen gets things kind of flat, and certainly in the middle it's going to be as flat as your platen or your glass on here, and the glass will wear. You got to change that out occasionally. That's fireplace glass is the generic term. The only glue that I've found, epoxy, is JB Weld. It's rated up to 550 degrees. Most other glues fail around 200, 220, 250 Fahrenheit. And that gets up to that easily from the friction on the belt and so on. So we just use JB Weld right in this area on both sides, because the washer is going to go there, the detent ball is going to track around, so on. But basically where those washers rest, that's where you want it to be flat. So that's where I'm going to mic. Now this piece of steel started off at around 135 when it was rough, and so I'm going to take a few measurements. 125, 126, 126, 125. So I'm good with that. We're within a thou all the way around. Now surface grinder, you can get down to half a thou, 2/10, depending upon the surface grinder. Mine only gets to about a half. So I can actually live with that, and it won't make a material difference in our folder. So we've got a liner, 2 liners, got a blade, pivot's going to go in there. Now we've got a washer there, got a washer here. I need to know how much those 2 washers plus that blade equals for down here where I put my spacer bar. That needs to be the thickness of the washers and the blade combined. I know the 2 washers are about 16 thou, and I know that blade, I'm going to call it 125 and 6612. So I need a spacer about 157 thou. Okay, now I've got this material here, and I just grabbed it. It's some G10. It's layered. It's got some black and gray lines in there, and that's going to go. That will look something like this. This is orange and black, but it will look something like that. And this spacer bar needs to be the same thickness as the washers and the blade combined, and that keeps everything parallel. This way doesn't bind the blade and makes your mech work better. So that thickness is 195. So 157's the goal. And I'll take it to the flat platen. Now again, we just talked about that. That's going to round over there, and it's going to round over there. But I'm quite a bit oversized, so I'm going to get this down into the 160 range, and then I'm going to move to the disc sander and finish getting that. And my concern is to get this area flat inside of here, where I can take my part. I guess I'll have to go look quite a bit bigger, where I can cut my part out, my spacer. My spacer is going to end up looking something like that. So this I took to the thickness that is the same as the blade and the washers. So here's back to the pattern. I'm going to stay away from the edge even though I used it on the disc, because the center part's going to be more true, flatter. Now that blade's going to come in there and that tip's going to end up somewhere there. So what I'm going to do is rough outline where I want to cut for my spacer, and we'll clean that up as we fit the knife. Alright, so there's the spacer bar. What we can do is we'll go ahead and drill that now. These are number 49 holes, then we'll enlarge those to through holes. This is a surface plate, granite, and they're pretty handy to have, and they just don't cost that much. So I've got a few burrs on there I just want to take off. I'm using a 360 just to get it flat. That'll go in there like that, and we'll get the blade in there. But first we're going to go reprofile this blade. This pattern is way oversized. You can finish it like that if you want a huge blade. I prefer kind of a clip point, so I'm going to come and reprofile this blade in, and I'm going to take off quite a bit of that belly, just something like that. I put some tape on here just to keep the scratches down from any grit getting next to the steel and so on. I can live with that. So you can shape this pretty much any way you want. Before we do the spacer bar, we wanted to get this blade profiled, find out exactly where that tip's going to land. That's where it's going to be. So now we can clean up that spacer bar. These are 1/2 inch 256 button head screws. We're just going to go through the back. I've got a pivot in there so I can see where that ends up. So we've got quite a bit to trim off here. Got some to trim there. So we'll take that back to there. We'll trim this off about right here. Then we'll get this spacer bar cleaned up. Looks pretty rough. Get that on the small wheel and clean that up. I'll just leave this outside edge. That doesn't concern me right now. I just want to get the inside where the blade has clearance to close. Okay. All right. So we removed some of the excess on the spacer bar and got it where it's all flush against the stop pin, well below there, so can't do that. We know the blade and the washer stack is 157 thou, and we used 76 thou. It's just a standard thickness they roll tie in. We call it 70. It's nominal 70, but it's really 76 thou. 90. So 309 is going to be that stop pin. So if we draw that stop pin here, we want it to not go any farther than the outside of that scale, but we want to use that whole scale. We want just a little bit shy of 309. So 309 is what we're going for on the length on this stop pin. I've got this, it's called a double-headed pin vise, and it's handy as dickens. It holds a 1/8 really easy. When you get down to that little bitty 1/8, it gets hard to hold. See how close I got? Oh, we got a long way to go. So that's 398. .312, and we'll shorten that up with the pivot lap. So these pivot laps are made for getting the ends perpendicular and exactly the size as you scrub it across your surface plate and some abrasive. And now it's not necessarily, but to do this you can do it manually, but this really is easier. Now these come with 3 different bushing sets. So we've got the 1/8. That's going to go down in there. Got a burr, so I'm going to put that through the bottom. So the bushing goes in there. The rough end goes down. And your plunger goes in. And it really squares that up and cleans it up. And we're at 308. I'm going to take just a bit more. Got a few thou that you can work with there, and just want that slightly undersized. Got the one side there. That one's already chamfered. These are hardened pins that come to us that way. I'm going to put a little bit of a chamfer on the edge of that so it's easier to go in and out of the hole. So just use this little pin vise, otherwise holding that little bugger is almost impossible. No washers in here yet. We're just taking a little peek. That's going to work. One of the things here that you want to watch for is if you're using a larger washer, you want to make sure that this does not interfere, the Lockbar action doesn't interfere with that, and we have a small enough pivot in there. Sometimes I'll put a bigger pivot on the other side, a smaller pivot on the Lockbar side, and a bigger pivot on the face side. I don't know if there's an advantage to it, it's just what I grabbed out of the bin. So you can feel the detent ball, grab it, pull it in. It's got a good feel to it. It's not loose, so it holds it in with sufficient force and it locks out. And now if you notice the lockup changed a bit. Now we don't have this tightened up, but the lockup was about 50%, now we're 25-30%. It does change a bit from grinding it to getting everything in place because you've got the stop pin firming everything up, and now we do not have the other disc pivot head put on here yet. And this is kind of the disadvantage of leaving that a little bit longer, is when you're working it up you can't quite snug it up and get the pressure set there and get everything firmed up. So what we're going to do is we're going to go back and shorten this to about 309 same as the stop pin. All right, I've got that shortened, rough ground, down to about 312. And I'm going for 305, that kind of range. And this is where these pivot laps really shine. You want a nice square surface to snug up against. I'm at 307. One of the things that you want to watch when you're trowel fitting is this steel isn't hardened yet, and so what you end up with is a wear track from your detent ball, because that's ceramic just under diamond hardness, and that will wear a groove in there. So you get away with a few trowel fits, and right now it's the surface, it's not digging in, but if we keep working that back and forth before it's hardened, you're going to wear a little groove in there. Now that's not the end of the world, it won't show, but why do it if you don't have to? You can get away with a little bit. Alright, so we've got kind of a roughed out deal. We're going to need some room there to get in and be able to push that lock bar over. So we're going to just take and this is just a design choice, what you like. We'll go back over to the horizontal small wheel. Now you can use any kind of small wheel, use a file, grind it out any way you want, but we just have it, so I'm going to use it. Okay. Yeah, that's good. I can get good grip in there, get that lock bar moved over. Now let's make a mark where the thumb stud's going to go, and that's a big knife. And so I'm going to put that right there, and I'll drill a 1/8. We're going to use one of these thumb shredder thumb studs. That's got a 1/8 boss, and it will hold a 256 screw. So get that drilled, fits in, and I dropped it down low enough where the outside diameter of that is not above the top of the spine. So that's set. Okay, we are pretty close to being ready to grind. Got all the heavy lifting done. Got scales that will fit in a bit. That can be towards the end. Main thing we're concerned about now is getting the mech all set up and ready to, and we will use the handle. We'll put it together and we'll use the handle to hold the grind. We're going to have some interference right there. So that will have to come ground, we'll have to grind that back. That's going to run into the stud right there. So again, this is oversize because we ground well outside of the scribe lines. You can see the faint outlines there. So we'll grind that back just far enough to clear the thumb stud. No big deal, but that's going to work. I get these awkward screws sticking out here. These are sacrificial. I'm going to just grind them flush so they're not in the way and grind the blade. The screws are 150 under the head, and so they may run into each other, and I think we're kind of hitting that now, even though, but we'll deal with that in a bit. And a lot of that excess, where right now the screws actually are touching each other and they just won't go in any farther, but that won't matter for grinding. And then when we do and countersink these scales, we'll have half the thickness of these, and that will easily take up any excess. Layout fluid on there, let that dry. This is an edge scribe that we sell. It's got a carbide scribe in there, and it's ground flat, and you can adjust the height up and down that way. And in use, drag it one way, drag it the other way, and what's left in between is going to be your center. And so the blade's around 125. Okay, so now I'll take that down to 6250. Lock it in. And this is hardened. I don't know if it's carbide or what, but it's hard. That's going to give me a scribe line right down the middle. I'm going to scribe the top also. As I'm checking my grind to see that I've got my bevels centered towards this scribe line. Also on the top, as you get a distal taper, I'll see that my tip up here gives me a guide to aim to get my tip centered also. All right, I don't know what grit this is, but it seems to be about an 80 or so. And that's a good place to start on something this thin. It's only an 1/8 inch. If it was thicker, I'd use a bigger one. And I'll take off 3/4 of the material with this. Now, one of the things with these Platens is, especially for flat grinding, these fireplace glass really does a great job reducing friction, reducing heat, but they do wear. And I've done some heavy profiling where my tabletop rests. There's a mark right there, and there's a divot. I don't want to flat grind right in there because it's not perfectly flat, and I'll be chasing my grind line all over. A little belt dressing on there. Now, that's just a lube stick, grease stick. What that does is it cools a little bit, and you get a cleaner grind. It won't rip out so much as it grinds away, and there is a difference. It gets to be a little messy. I use it on and off. I don't use it on everything, but occasionally I do. And something like this thin, where I don't want a bunch of scratch marks in there and gouges that I gotta clean out later, definitely use it now, and I'll probably use it on some other grits later on. So I put a line right there, and that's as far back as I'm gonna go. Just like grinding a knife, you've seen it a million times. We'll see in a bit. I'll get through this and we'll get it all ground out.